If a program's memory usage is suddenly ballooning in size, it may have what's known as a memory leak. In today's episode, we'll explain what a memory leak is, how they happen, and how some programmers are protected from them. Welcome to Kopek Explains Software, the podcast where we make computing intelligible.
This is a follow-up to our last episode. We're talking about memory and memory leaks. So what's happening in the software when there's a memory leak?
A memory leak occurs when some memory is allocated, and it could be for anything. It could be for a picture, it could be for some internal data structure, it could be for some text, it really doesn't matter. And it isn't freed. So every time we want to use memory, we have to say to the operating system, here's some memory I want to use, and that's called allocating memory. And when we're done with the memory, we have to tell the operating system, I don't need this memory anymore. You can go use it for something else. That's called freeing the memory. And you have to free the memory so that it can get reused by other programs or even by your own program. There is a finite amount of physical memory in any computer. That's why we can't just keep allocating memory and not freeing it. So a memory leak occurs when some memory is allocated, it might get used for something, and then it's never freed. That means that memory essentially got locked up without ever getting reusable by somebody else or by your own program.
How do you know that a memory leak is happening on your computer?
Yeah, it's not completely obvious. It's not like you're just going to get a pop-up that says, hey, I'm leaking memory. These are sometimes somewhat subtle bugs, especially if the amount of memory being leaked is actually quite small, and it just accumulates and becomes a problem over time. So the way you're going to see this is in the Task Manager in Windows or the Activity Monitor on macOS. These programs are ways for you to observe the memory usage, CPU usage, network usage, disk usage of the programs that are currently running. You can look at the memory usage of a currently running program, and if it continues to increase over time for no observable reason, and it just gets larger and larger and larger, it just continues to balloon over time, and it's not like you were opening new documents, or it's not like you were doing things that would cause more memory to be used, then a memory leak may be occurring. So that's how you as a user can identify a memory leak. As a developer, as a programmer, we can identify memory leaks using debugging tools. And so we have actually specialized tools, profilers, to help us figure out that memory leaks are occurring. They're not perfect. It doesn't mean that we're going to catch every one. And sometimes it's hard for these tools to really know that we meant that we wanted this memory to be freed and reusable. So it's possible that these tools can fail sometimes as well. But as a user, if you really see a program over time using a large amount of memory and it doesn't seem like you're doing anything in it to really cause it to use a large amount of memory, and that number in the Activity Monitor or in the Task Manager is just getting larger and larger and larger, then it's very possible that that program has a memory leak.
There are some programming languages that have a protection built in to help developers with preventing memory leaks. Is that right?
That's right. Older programming languages have what's called manual memory management. This meant the programmer themselves had to do some bookkeeping. They had to keep track of every bit of memory that they allocated so that they would remember later on to free that memory. Programming languages that had manual memory management that are still used today, and actually very popular programming languages, are C and C++. There are others as well, but those are the two most common, and they're used everywhere. And we've done prior episodes on both of them. Anyway, they have manual memory management, meaning that every time you allocate some memory in C, you need to remember to go and free it later on. However, most modern programming languages use what's called garbage collection. In garbage collection, you still allocate the memory, but you don't have to worry about freeing it. It's all done behind the scenes transparently for you. There's a runtime mechanism implemented at the programming language level that keeps track. It's a runtime that keeps track of how much memory has been allocated, what objects are using that memory, and then when those objects are no longer needed, that memory is automatically freed. So this eliminates a whole class of programmer errors. It eliminates a whole class of programmer errors caused by a programmer who wasn't doing the right bookkeeping. They weren't remembering, oh, I allocated that memory. I actually need to free it later on. So programmers generally find using a programming language with garbage collection very convenient compared to having to do manual memory management. The downside is they don't get as fine-grained control over the usage of memory. So it might be up to the programming language runtime when that memory gets deallocated. And if it gets deallocated at an inopportune time, it can actually cause a performance problem. So programmers who are performance freaks or are writing programs that just really need to be very high performance sometimes prefer manually memory managed languages.
How does protected memory and memory leak connect?
Yeah, last week, and I'll put a link to it in the show notes, we talked about memory protection, which is the idea that one program's memory space is separated from another program's memory space and they can't affect one another. If you have a memory leak and it's in a userland program, then in a modern operating system with memory protection, it should only be that program that's ballooning. And that memory leak is never going to cause the program's memory space to get so large that it went past the end of where it should be and started invading the memory space of another program. So if a program has a memory leak in a modern operating system, when it gets terminated, either naturally or forcefully, then it will not actually cause the system to come down, and hopefully all of that leaked memory will go away and won't in any way affect any of the other programs that are running. So if you have a program that has a memory leak in a memory protected operating system, once that program is shut down, that should be the end of the story. In an older operating system, it's possible that the program would balloon to such a size that it would start actually invading the memory space of other programs if that multitasking operating system did not have memory protection.
We're seeing an issue with a memory leak happen right now for the new operating system that Apple just released.
Yes, Apple released a new version of macOS called macOS Monterey. It came out a few weeks ago, and people were very confused when it first came out why programs seemed to be ballooning in memory size. And it was very hard to track down. Nobody knew why this was happening, and it seemed to be happening across many different kinds of programs. So one person would be reporting, oh, Firefox is suddenly using 80 gigabytes of memory, which is an insane amount. It's more than the physical memory in any current device that Apple is selling. So it would have to be going into virtual memory, which is a whole topic that we might cover in another episode. Anyway, people were like, why is Firefox using so much memory? But then somebody else was saying, hold on a second, why is Photoshop using so much memory? It's gotten so large. There must be a leak. Everyone agreed that there was a leak, and no one could figure out what is causing the leak. And then a very talented investigator figured out it was actually being caused by a new accessibility feature in macOS. And this is going to sound kind of bizarre to everybody. But basically, in the new version of macOS, there's an accessibility feature related to what the pointer looks like, what the icon for the mouse looks like on the screen. If this accessibility feature is turned on, there is a small memory leak every time the icon changes. When does the icon change? It changes, for example, you might have the main arrow pointer and then you go to enter text in some text box and it changes into the I-beam where you enter your text. Or maybe you're in a web browser and you're on a button and then you get that kind of glove with the index finger out. So every time that icon changes was leading to a small memory leak. Now, the problem is certain programs, that icon is changing all the time. If you're in a web browser, you're all the time hovering over buttons, then not hovering over buttons, then hovering and entering some text, then not hovering and entering that text. And if you're leaking even a little bit of memory every time the icon changes and the program is going to cause you to change the icon all the time, you're going to end up leaking a lot of memory. And so this is actually pretty crazy because this was not something that an application developer did. This was actually a bug on the part of Apple. Apple had this bug in macOS, and look, the people who work at Apple and Microsoft, they are human beings like the rest of us, and they make mistakes. So we're not here to just say like, oh, it's so inconceivable that there would ever be a mistake made by them. But you can see how when a mistake like this is made at the operating system level, it leads to unintended consequences for a lot more people than when a mistake like this is made at just the program level. So anyway, this bug is actually present still in macOS, and of course, I'm sure Apple is patching it, and I'm sure a update to macOS Monterey might even come out by the time this episode comes out. But it's pretty crazy to see these bugs in the real world and how much they really affect people. There were people saying, actually, right when Monterey came out, so did some new laptops from Apple. And there were people posting on forums saying, you know what, I'm going to return the laptop because I don't think it has enough memory. they were getting out of memory errors, and they were like, wow, I should have bought a laptop with more memory. And they were I know a couple people who I know through online who went and returned their laptops and went and bought laptops with more memory because they thought, oh, my programs keep running out of memory. I guess I didn't buy a computer with a high enough capacity. So these errors have really real world consequences. They're much more common though in individual programs. So yeah, this was a special case recently that happened in macOS, but it's much more common that programs will have memory leaks. And actually, this is a very common type of programmer error. I've made the mistake myself in a couple programs where I've had significant memory leaks. So these happen all the time. The good news is, because thanks to memory protection, they tend to only affect one program at a time, and we can always just quit the program and reclaim the memory. But unfortunately, when they happen like they happen in macOS Monterey, then they really affect everybody. And we should also say there's really nothing you as the user can do to protect yourself from these memory leaks. They are truly a mistake on the programmer's part. Programmers can try to protect themselves by using modern languages with garbage collection or by running tools that check for memory leaks before they release a program. But as a user, all you can try to do is report them to the maker of the app that has the problem that you've identified, because you see it blowing up for no reason in Task Manager, and hope that they can then quickly identify the problem and put a patch out. And for the program that's having the leak as it's running, what you can do is just force quit it. So Control-Alt-Delete, go into the Task Manager on Windows, or Command-Alt-Escape on macOS, and force quit the app. And that will free up all that memory to be reused by the rest of the operating system and other programs. So again, because of memory protection, you hopefully shouldn't be affected once you've quit the app. Thanks for listening to us this week. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
Thanks for listening, and we'll see you next week.
Bye.